All right, geometry students, so today's lesson is all about parallel lines and triangle angle sums and how they're related. So to be successful today, we should be able to discover and apply the properties of interior and exterior angles of triangles to solve problems. So in our lesson, we're going to be proving two theorems. We're going to prove the triangle angle sum theorem and the exterior angle theorem, and then use those theorems to find missing angles. To be successful, make sure that you have your guided notes open and you're following along. So let's get started. So before we move any further, I want you to stop here. What I've done is I've linked an additional video. It's a really short video that really explains and proves the triangle angle sum theorem well, just using visuals. And it talks about how the sum of the measures of the angles of any triangle is 180 degrees. So please watch that proof. Take a second. And once you're back, we can fill in our notes. And now that we've proved that theorem, we know that the sum of the measures of the angles of a triangle is 180 degrees. In this specific diagram, we know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. And that's true for any triangle. Now let's actually prove the exterior angle theorem together. You'll see in this diagram below we have a triangle and we have angles 2 and 3. 2 and 3 are what we call non-adjacent interior angles. Non-adjacent interior angles in their relationship to angle 1. So what we've done is we've extended the line that forms the base of this triangle, and that includes angle 1. Angle 1 is an exterior angle because it's outside the triangle. So in this theorem, we're saying that an exterior angle is always equal to the sum of the two non-adjacent interior angles. So this theorem goes like this. The measure of angle 1, the exterior angle, is equal to the measure of angle 2 plus the measure of angle 3, those two non-adjacent interior angles. And here's a reason why that works. So let's just redraw a diagram. It doesn't have to be too fancy here, and it could be a different kind of triangle. Doesn't really matter. So we have angle 1 on the outside. Let's call this a 100-degree angle. This angle is 100 degrees, and we know. Let me backtrack for a second. I'm just going to give the interior angles for a second. So let's say we've got a 60-degree angle and we have a 45-degree angle. And we don't know the measure of the third angle. So let's try to find that. Let's use the triangle angle sum theorem to figure that out. Well, I know that this missing angle would be 180 minus these two given angles, 60 and 45. And so that I know 180 minus 60 minus 45, well, that would be 75 degrees. And so what's cool about what's next is we know that this 75-degree angle and this missing angle on the outside are a linear pair, which means they have to add up to 180 degrees. So 180 minus 75 would be 105 degrees. And now you'll notice that the exterior angle is now equal to the sum of the non-adjacent interior angles. 60 plus 45 is 105. So that is one way to prove the exterior angle theorem. Another way is to use a parallel line relationship, but I can get into that in another video. So now let's use those properties to solve some problems here. And so we're going to find all missing angles in the diagrams. For number 1, we'll notice that we're just given one triangle, no exterior angles involved here. We know 2 of our angle measures. We're asked to find the third angle, angle 1. So we know that using the triangle angle sum theorem, the sum of the angles in any triangle is 180 degrees. So this is a simple one. Take the sum of the angles and subtract what we know. We know there is a 24-degree angle and a 37-degree angle. 180 minus 24 minus 37 is 119 degrees. So the missing angle would be 119 degrees. In number 2, we are seeing an exterior angle given here, and we're asked to find the measure of angle 1. So again, 2 ways to go about this. We could find the measure of this third interior angle by subtracting from 180, or we could just use the exterior angle theorem, which says that 76 plus 52, the sum of the measures of these inside angles is equal to the exterior angle. So let's just do that. 76 plus 52 is 128. So the measure of angle 1 is 128 degrees. And we've got one more simple problem here. We're given one interior angle in this triangle, and the other interior angle is missing. But we do know the exterior angle, and that's 104 degrees. So let's just set up an equation using the exterior angle theorem, which is going to say that the sum of these 2 interior angles, measure of angle 1 plus 79 degrees, is equal to the exterior angle, 104. And from there, we just know that we need to subtract 79. And so the measure of angle 1 is just going to equal 104 minus 79, which is 25. The measure of angle 1 is 25 degrees. Now let's make our problems a little bit more difficult here. So in number 7, I'm skipping down a ways. I am given that segment BC bisects angle ACD, and the whole goal of this problem is to find the measures of all the missing angles. So if segment BC bisects angle ACD, well, I know angle ACD is this right angle here. That's what I know. And if you bisect a right angle, if you bisect a 90-degree angle, cut it in half, that means you're creating 2 45-degree angles. That means that angle 2 and angle 3 are each 45 degrees. So that solves a lot of our problems right there. So angle 2, and I'm just going to label in the diagram, 45 degrees, and angle 3 is 45 degrees. So now we just need to find the measures of angle 1 and angle 4. And what I'm seeing in this diagram is I'm seeing 2 triangles kind of stacked on top of each other. Let's look at the top triangle ABC. the top triangle. Now I know that it has a 48-degree angle and a 45-degree angle. So to find the measure of angle 1, I'm going to take the sum of the angles in a triangle, 180, and subtract my given angles. So subtract 48 and 45. And so 180 minus 48 minus 45 would be 87 degrees. The measure of angle 1 is 87 degrees. Now we can do the exact same thing with the smaller triangle at the bottom. That's triangle BCD. I know that I have a 45-degree angle and an 83-degree angle in that triangle. And now I just need to use the angle sum theorem to find the missing angle. So again, 180 minus 45 minus 83, and that will give us the measure of angle 4. 180 minus 45 minus 83 is 52 degrees. There you go. We successfully found all of the missing angles in that triangle, or in that diagram rather. Let's switch up our colors here. In problem 8, I'm given a much different diagram, a lot different angles, and I'm asked to find the measures of angles 1, 2, and 3. So I'm seeing two triangles. If I try to process what I'm seeing, I see a larger triangle with two given angles, a 75-degree angle and a 41-degree angle, and I don't know the measure of angle 1. And then I see a smaller right triangle. You have a 90-degree angle, a 54-degree angle, and then we are not given the measure of angle 3. What I want to do is I want to use the triangle angle sum theorem to find the measures of angles 1 and 3. This is the easy stuff. This is what I know how to do. I'm not quite sure how to find the measure of angle 2 yet, but we will cross that bridge after we find angles 1 and 3. So to find angle 1, we are going to subtract the given angles from 180 degrees. So 180 minus 41 minus 75. And the difference would be 41 minus 75 would be 64 degrees. I know that the measure of angle 1 is 64 degrees. Now with my smaller triangle, I have a 54-degree angle, a 90-degree angle, and an unknown. So the measure of angle 3 would be 180 minus 90 minus 54, and that gives me a 36-degree angle for angle 3. So now we need to find out what's the measure of angle 2. And I'm going to label what I know in my diagram now. So I know that angle 3 is 36 degrees, angle 1 is 64 degrees. So to find angle 2, I notice that it's on the same line as this 64-degree angle and this 90-degree angle. Let me redraw so you can see what I mean. I'm going to redraw just with these angles without the triangles involved. So I've got, this is just a rough sketch here. So I've got my 64-degree angle. I've got angle 2. And I've got my 90-degree angle. So really, since they are all on the same line, that means their measures should add up to 180 degrees. So let's use that same property to find the measure of angle 2. So it would be 180 minus our given angles. That's a 64-degree angle and a 90-degree angle. So 180 minus 64 minus 90 would be 26 degrees. There we go. For additional practice, you can practice problems 4 through 6 and 9 through 11. 4 through 6 are a little bit more simple. 9 through 11 are going to be a little bit tougher than the problems we practice in this video. So that is it. That is our video. Thank you so much for watching. Make sure that you are trying out the additional practice problems. Not all of them, but you do want to make sure that you're trying enough to fully understand these concepts. Make sure you check your answers with my filled in notes, and you can find those in the content library under the Topic 2 Notes tab, and ask for support in Math Help Desk if needed. Thank you again for watching this video.